All right, grade 10s, this is going to be your introduction, I guess, if you're not in class. But the powers and exponents, this is right out of grade 9. Almost everything that you're going to see in this unit, you'll have seen in grade 9. It'll seem all new and fresh, but it really isn't. It'll be review, a little bit of getting used to it. But here, these 5 are the 5 rules that you learned in grade 9. Okay, and we'll do examples of each one kind of on its own. And then the fraction exponent rule, or the rational exponent rule, is the new addition to it, okay? Because at the end of this unit, we're going to start dealing with radicals, and that's kind of where we bring them in. So I'm going to jump right into it. So again, the first 5, you already know, you just may have forgotten. It's been a long time, or given the situation, okay? So let's jump right into the product rule and see where this goes. So I'm going to carry that down here, and we're going to say, okay, the product rule. That's where we're starting. Product rule. Number 1. So I call this the definition of the product rule, all right? So it looks like this. If you have any base to an exponent, a, or the whole thing's a power, but you'll hear people interchange the word exponent and power quite often. So the base x to the power of a, as long as you've got the same base, and that's the key with exponent rules, is you need to have that common base. The exponents can be the same or different, doesn't matter. We're just calling them a and b here for our purposes. So here's the definition. When you're multiplying, which gives you a product, hence the name product rule, when you're multiplying common bases, so you'll notice the x here and the x here, if they have exponents, even if they don't, if you just have a variable x, well, that really has an exponent of 1. It's just not, we don't commonly write that, okay? So these guys have a common base of an x, so we're going to say x to the a plus b. And this follows the whole expanding stuff that we generally know from just exponents in general. So I'm going to do a quick example over here. I'll squeeze one in. I'll put it in green so we can really see it here. Let's do a simple one like 3 to the 4. And let's times that by common base 3 to the 5. All right. Now, if I use what we know about expanding out exponents, being that that's what an exponent tells us to do, is multiply a base by itself that many times. So for instance, this 3 to the 4, that means I'm going to multiply the base 3 by itself 4 times. So I'm expanding that out. And then that's all multiplied by, again, we have another 3 to the power of 5. So I'll say 3 times itself 5 times now. And we can count these up. I've got 4 there, and I have 5 of them there. Well, instead of expanding those out to simplify it to 3 to the 9, I could have recognized I had a common base 3. I'm multiplying those common bases. So what do I do with the exponents? I add them up. 4 plus 5 gives me my 9, and there's my answer. All right? So let's do another example on the next page. All right. Let's go like this. Let's go with letters this time, or variables. Let's go a to the 4. And you might see it written with a point multiplication, times a times a to the 3. I like this question because it's not a trick question, but it'll catch a lot of students this way. Okay, so the first question I always ask myself when I'm dealing with exponent rules is, do I have common bases? If I have common bases, I can jump right into it. So yes, I have common bases. The a's are my base. I'm multiplying. That tells me what rule I have to follow, so I got to use a product rule. So what's product rule says? It says you add your exponents. So a lot of people say, oh, okay, so 7. Well, remember what I said just 30, 40 seconds ago, that even if you have a base like this A right here, with what looks like no exponent. Well, there's still 1a there, right? So you could think of that as a 1. I don't put those 1s there. I just treat them like that. So I look at it and say, okay, I got 4 plus 1 plus 3. I can say my answer is simplified to a to the 8. And there's my answer. Finished up. Simple. Okay, let's do another one and we'll evaluate it this time. Let's go with, oops, shouldn't have done that. Okay, let's go with 2 to the 3 times 2 squared times 2 to the, let's go 2 to the 4. Now, what I don't want to see you doing is using calculators. Calculators, you might as well throw them in the garbage because it's not the point of these assignments. It's not the point of the outcome. The point of the outcome is to know what the rules are. And you should know all your powers of 2. Well, you should know all your powers up to 15 squared for sure. You should know all your powers of up to, I would say, 6 cubed. But your base 2, you should know up to about the power of 10, so 2 to the 10. So let's simplify this and we'll evaluate this. Evaluate just means give me a single answer. Unlike on this page where I left it as 3 to the 9, that to me is a big dumb number. I'm not even going to evaluate it, but we're gonna take this big dumb number and we're going to evaluate it. So I look at my bases, they're all the same. I'm multiplying them, so that means I add my exponents. So I get 2 to the 5 plus 4 is 9. Okay, one step further when I evaluate, well, 2 to the power of 9, if we don't know it already, that's okay, we'll get there. Let's see, 512 is our final answer, right? Because you think, as you go up 2 times 2 times 2 times 2, 9 times will give you an answer of 512. So that's if you use the rule and evaluate it. And you'll see that as we go along. I don't expect you to evaluate these very often, but in the case that I do say to evaluate it, go ahead and evaluate it.